Good evening, everyone. Thanks for joining in this webinar. And in today's webinar, we will be explaining about this lightning protection system design for solar farms. So, in our previous webinar, we have explained about this lightning protection system design in detail. So, among those methods, we will be explaining the methodology that will be very specific to solar farms and what are all the other criteria that has to be considered while designing lightning protection system for solar farms. So, we will be explaining the protection methodologies in detail that will be very specific to solar farms in this webinar. So, before entering into the topic, a small introduction about our company. CIKIT was incorporated in 2018. Even though it is a 4 years old company, we are having an experience of more than 17 years in this field of lightning protection and ethics. And our specialization is we are providing end-to-end solution for lightning protection and earthing issues. And we are providing customized solution based on the specific site conditions. So rather than providing the generalized solution for all the site conditions, we will be analyzing that particular site condition and we will be providing a customized solution as per the standard specific to the field. So if you take this solar field, there are so many standards which explain about it. In specific, recently IS has launched 17978 and NBC has provided some regulations regarding this solar farm. So while providing solutions to solar farm, we will be referring to those specific standards rather than referring to generalized standards. So we will be providing customized solutions based upon the site conditions. So these are some of the standards which we refer for lighting protection systems and designing in this. For the long period, we don't have any standards which explains about this protection methodologies for solar farms. Recently, in 2020 only, IS has published the standard 17978, which explains about lightning protection system and surge protection for solar farms. And apart from that, we will be referring NBC 2016 also. So in NBC 2016, they have provided the limitations on height of the air terminal. So they have mentioned that the height of the air terminal can be only 500 mm above the panel to be protected, because if I increase the height of the air terminal, then the shadow of the air terminal will fall on the panels and this shadow will affect the power generation. So in order to provide protection, we should not hamper the power generation. So NBC has provided restriction on height of the air terminals above the panels, and we can have air terminals of 500 mm height. We cannot increase the height further because of the shadows. So these are some of the damages recorded due to lightning. So in general, almost 35% of damages in solar farms are caused by this lightning. So while lightning happens, there will be a huge amount of heat produced. And if we take the solar panels as an example, we are having three types of solar installations. One will be rooftop, second one will be ground mounted, and third one will be floating solar. In all these cases, these panels will be at the topmost point. So if any lighting happens on that particular area, the first point of contact will be the solar panels. So if we are not providing any protection against lightning, then the panels will get damaged because of the lightning. And apart from this lightning directly striking on this panel and causing the damages, it can also cause damage to the solar equipments during the by means of electrical surges. So in this case, the electronic components are damaged because of electronic surges, because of the surges through the power line. So apart from lightning directly striking on the structure and causing the damage, the lightning can also cause damage through the power line and data line in the form of surges. So while providing protection, we have to provide protection for both physical damages as well as the failure of electronic equipment as well. So this is what we explained, the three different types of installations. So in this, we can observe that we are installing the solar panels on the top of the terrace. So we are covering the entire terrace with solar panels, and this solar panels will be the highest object on the terrace. So if any lightning strikes, then obviously it will land on the solar panels. And if you take the second one as an example, this is the ground mounted solar. So for megawatt scale projects and that, we will be going for ground mounted solar. And it occupies more than hundreds of acres based on the capacity of the plant. So in that area, there won't be any other structures and solar panels will be the only structure. During lightning, what happens is charges will get induced on all the objects that are connected to the ground. For example, if you take this cloud, and usually positive charges will get accumulated on the top portion of the cloud, and negative charges will get accumulated on the bottom portion of the cloud. And during lightning, that is thunderstorm conditions, this negative charges in the cloud will induce positive charges on all the objects that are connected to the ground. So in this case, this metallic frames are also connected to the ground, and this ground will be also sending the positive charge. Metallic structures will be also sending the positive charge, and electricals will be discharging from the ground cloud. So since all these structures are connected to the ground, and this is also sending the positive charges, the probability of lightning discharging through this panel body will be much higher. So in this locality, there won't be any higher structures as well. So for hundreds of acres, only the solar panels will be the tallest structure. So the probability of lightning striking on the solar panels is much higher. So we need to provide proper protection to avoid the damage of panels from this lightning. And third type of installation is the floating solar. So this one is slowly developing in our company. We have very few installations on this floating solar when compared with the rooftop and the ground mounted solar. So in this floating solar assembly, we will be arranging all the solar panels on the water bodies. So for installing the panels on the water bodies, we will be providing an insulated floating material. So that floating material will be made to float on the water bodies, and on the floating materials, we will be installing the solar panels. So this one is slowly we are developing in this floating solar concept. And in this case also, the panels are surrounded by water body. So in that case, the lightning striking on the water bodies may land on the panels because if you compare the level of water and the level of panel will be at some height when compared with the water body. So if any lightning is striking on those water bodies, then definitely it will strike on the panels instead of striking on the water. So in order to provide protection, we need to properly design and execute the sufficient lightning protection system to avoid the damages. So in this webinar, we will be discussing about what are all the different methodologies that we can use and how can we install these air terminals for this kind of solar installations for ground mounted, for rooftop, as well as the floating solar arrangements. So before going into the solution, we need to identify what is the real source of the problem which we are facing. So if you take the damages due to lightning in solar farms, so as we have already shown in the images, so lightning can directly strike on the solar panel and cause damages. So if any lightning is striking on the panel and it may cause failure of the panels. That is called as direct effects of lightning strikes. So in this case, lightning is directly striking on that particular panel and that particular panel is damaged. It is called as direct effect of lightning strikes. So in the second slide, next slide, we have shown the failure of electronic components. So in that case, lightning is not directly striking on the device. Rather, the lightning strikes on any other location and it causes failure of the electronic equipment in some other place. So when the lightning striking is some other place and the damage is felt is some other place. So that is considered as indirect effect of lightning strikes. So if you take the solar, we are laying the cable all over the plant for this interconnecting the solar panels with the string modules and connecting the string modules with the inverter and for connecting this inverter to the substation. So for all these interconnections, we are using cables and these cables are running throughout the plant. So in addition to this direct lightning effect or direct effects of lightning strike, the surges induced on these power lines due to this lightning will also cause damage. So in solar panels, direct effects and both indirect effects has to be considered while designing these lightning protection systems. So as I mentioned, the indirect effects is due to the surges induced. So the indirect effects can be caused by three ways. First one is so lighting near the structure. So if lighting strikes near the structure, for example, in your case, if the lighting strikes near this panel, then what happens? At the time of discharge, the entire ground potential will rise. So the ground potential itself will rise at the time of discharge. So because of this increase in ground potential, there will be some surges induced on the power line and the data line. So if I am taking any DC cable from the solar panel to inverter, if any lighting strikes near to this cable, then because of this increase in ground potential, there will be some chances of induction on the cable. Since we are connecting this cable to inverter, the electronic equipments in the inverter may get failed. And second option is lighting checking on any power line. So if any lighting checks on the power line, then the surges will travel through the power line and it will enter into the structure. So this the electrical equipment will get failed. And the most important thing and most people are unaware of is fourth source, that is lightning strike near the power line. The lightning striking on a power line can cause damage, but how a lightning striking near the power line can cause damage to the equipment. So we are all aware that whenever current flows through any material, magnetic field will be produced. So electric current and magnetic field cannot be separated. So whenever current flows through any material, definitely magnetic field will be produced. So if I lay any power cable or data cable near this conductor which carries this lightning impulse current, then there will be some induction on this power line. So, because of this induction, the surges will travel through this line to the equipment and it will result in failure of electronic equipment. So, the lightning striking near the power line will cause failure through this magnetic coupling. So, the magnetic field is coupling this power line with the conductor carrying this lightning impulse current, and through that, the electronic equipment will get damaged. So these three things are called as indirect effects of lightning strikes. And the direct effect is lightning directly striking on the panel or any other structure and causing this damage. So in case of solar projects, the indirect effects also causes damage as severe as the direct effects of lightning strikes. So by providing complete solution, we have to provide both this protection. We have to provide protection against direct strikes as well as we need to provide protection against the indirect effects as well. So we have already explained about this over lightning protection system in our previous webinar. So I'm just giving an outline about for this. So if you want much more in detail, we can refer the webinar about lightning protection system design as per 62304.3. So as I mentioned, by providing protection, we have to protect from the direct effects as well as the indirect effects. So by providing this external lightning protection system, so external lighting protection system consists of three components. One is gap terminal, ground conductor, and third one is earthing. So by providing external lighting protection system, I am providing protection to the physical structures alone. So even after providing this external lighting protection system, these electronic equipments are not protected because these equipments are getting power supply from outside. So by providing protection, I am using external lighting protection system. I am protecting the structures alone. So if any lighting strikes on this power line, then the surges will travel through this and it may cause failure of electrical and electronic equipment. So if I want to provide complete protection, then in addition to this external lighting protection system, I have to provide internal lighting protection system as well. So the internal lighting protection system contains surge protection devices. So the surge protection devices will divert these surges that is coming through either power line and data line into the ground. So the combination of external lighting protection system and the internal lighting protection system will provide the overall protection. So if I want to provide complete protection, then I have to provide combination of external lighting protection system and the internal lighting protection system. Only providing external lighting protection system will protect the structures alone and it won't protect the electronic equipments inside the building. So the external lighting protection system mainly consists of three components. So the air terminal is the component which intercepts the lightning and down conductor acts as a bridge between the air terminal and the earth and the earth is the part which dissipates energy into the ground. So these are the three main components of external lightning protection system. There are two more option items. One is lightning event counter, and one is testing. So the purpose of lightning event counter is to just register the number of impulses captured by this lightning air terminals. And the purpose of testing is to just act as a testing for testing the condition of earthquakes and to check the continuity of down conductors. It is which main purpose is to check. That is inspection. Next, lightning event counter and testing for option items, whereas the other three are mandatory. So the standard has explained about three methodologies, that is 62305 part 3. So 62305 part 3 has explained about three methodologies for determining how to determine the number of air terminals required for protecting a structure and what will be the position of each air terminals. So these are the three positioning methodologies provided by 62305. And among these three methods, the rolling sphere method is the commonly used method for solar farms. So I am not explaining about these two methods, protection method and mesh method, and we have already explained everything in our previous webinar about lighting protection system as per 62305 part 3. So we have already explained everything about these two methodologies in our previous webinar. So if someone haven't attended the previous webinars, we can refer this webinar. And in today's session, we will be explaining only about this rolling sphere method. So, in rolling sphere method, what you will be doing is, you will be rolling an imaginary sphere of a radius r over the structure to be protected. So, here we have shown a house as an example. But in case of solar farms, we will be rolling the sphere over the solar panels. So, the main thing is, the sphere should not make contact with the structure. It can make contact only with the ground and the air terminals place. If the sphere makes contact with any portion of the structure, then the particular portion will be considered unprotected. So if you take these different levels, for level 4, we will be going for 60-meter radius sphere. So if the radius is 60, then the diameter will be 120 meters. Such a huge imaginary sphere will be rolled over the structure to be protected. And the sphere should be ensured that it can make contact only with the ground at the air terminals. It should not make any contact with any parts of the building. So this is a reference provided by IS 17978. So in this we can show that the sphere is rolled between two air terminals. So this is the air terminal. And this is one air terminal. Here they are rolling an imaginary sphere over the air terminal. And here they have set the radius as r. Hence, for level 4, the radius will be around 60 meters. And for level 3, it will be 45 meters. So if I am going for level 3, then I will be rolling an imaginary sphere of radius 45 meters. So IS 17978 has mentioned that it will be preferable to go for level 3 protection for solar farms. But for better results, it is always recommended to go for risk assessment calculations, and based on that, we can select a suitable level of protection. And from this image, we can observe that the shadow has to be considered while placing the solar panels. So here they have placed the solar panels in such a way that the shadow won't affect the power generation. So we have to perform proper shadow analysis in placing the position of solar panels. And We have to provide sufficient spacing between this gas terminal and solar panels, and the height of the gas terminals above this height also has to be considered. So, NBC has mentioned that this National Building Code 2016 has mentioned that the height of the gas terminal can be only 500 mm above the panels. So, this height has to be maintained 500 mm as per the regulations from NBC 2016. And while placing this air terminals and solar panels, we have to consider the effect of shadows. So the 500 limitation is provided only to avoid the effect of shadows. Based on that, we have to place multiple air terminals to provide protection to us. And in this, they have explained about both the things. So the spear light is for explaining about this rolling sphere method, and they have marked the protection using this protection angle also. So this is as per protection angle. So in many cases, we will be going for this rolling sphere method, and we won't be preferring protection angles because the area to be protected will be much higher in case of solar panels, and it will be very difficult to perform designing as per this protection angle methods for such a huge area. So we always prefer rolling sphere method for designing lighting protection system for huge areas, and standard also explains everything based on this rolling sphere method. So if we are rolling an imaginary sphere between any two points, then obviously some portion of the sphere will be coming below the level of air terminal. So for example, in this case, if this is the level of air terminals, then some portion of sphere is coming below the level of air terminals. So this level will be considered as penetration distance. So if I increase the spacing, then some more portion of this here will be coming below this that level of awareness. And if I increase further, then at some point the sphere will be making contact with the structure to be protected. So this distance will be considered the penetration distance. The level of sphere that is coming below the level of awareness. So the sphere should not touch the structure to be protected. So the distance between this diagonal should be maintained in such a way that the sphere won't make contact with the structure to be protected. And for all the structures, we cannot roll the imaginary sphere to find the position of diagonals. So the standard has provided a formula which explains about this maximum distance that can be provided between two diagonals. So the distance depends upon two parameters. One is penetration distance, another one is radius of sphere. So the value of R depends upon the level of protection. So whereas the penetration distance is what we are considering. So if there are any other objects, then I can reduce further. If there are any objects present here, I have to reduce the penetration distance. So based on this site condition, we have to determine the penetration distance, and the value of R will be constant. So by using this formula, I can calculate the maximum distance between two air terminals so that the structure can be protected. So in protection angle method, we will be calculating the radius of protection, whereas in rolling sphere method, we will be calculating the distance between two air terminals. So it is not the diameter, it is the distance between two air terminals. This is what I have explained. So if I increase the distance, so in this case you can observe. This is the bottom level of sphere. So here I am increasing the distance further. So if I increase the distance, then some more portion of the wall is coming below this level. And if I increase the distance further, then some portion of the sphere will be making contact with the structure to be protected. So if it is just making a point, then in this case, if it is just touching, then the penetration distance will be equal to height of the atom. So if the penetration distance is equal to height of the atom, then the sphere will be making contact at the center point. So it should not happen. So if the penetration distance and height is equal, then at the center point it is making some contact. So in order to avoid that, we always have to keep the penetration distance less than the height of the atom. So So it should be always less than 5 so that the sphere holds the making contact with the structure to be built. So we have performed calculations based on the formula provided in the standard for different height and different levels. So if we take this NBC as a reference, they have provided the maximum distance between two atoms is 0.5 meter, that is 500. So if I consider 500 amount, then the maximum distance can be only 15 meters if I am going for level 4 protection. So if I am going for level 3 protection, it is only 13 meters. So here the maximum distance only can be 15 meters. So in this case, I have to place multiple air components to provide a huge space for solar panels. So the IS 1798 has mentioned that we can place the air panels directly on the structure to be protected itself. So in this case, we can place this air panels on the mounting structure. So if we get this is the solar panel mounting structure. We can place the air terminal on the motion structure itself. So as per NBC, the maximum height can be only 500 mm above the panel. And if you take the solar panel arrangements, so consider this as a huge solar form. Consider this as a solar form. And all the solar panels are arranged in multiple rows of components. So in this case, if one side will be at lower height will be lower, another side will be at a different height. So this will be the highest one, and one side will be the lowest one. So if I am placing laterals, then I have to go for this highest height one. So in this structure, if you consider this point as higher, then I cannot place this lateral on this side because this will be lower side. And another point I can place is another row, top side of the another row. So like this only I can place. So as per the calculation, at level 4, the maximum distance can be only 15 meters. So if you consider this as a rectangle, so in rectangle there will be two sides. One is length, another one is width. So here the maximum distance is 15 meters. So if I mention this L is equal to 50 meters, then in this case the diagonal will be greater than 15 meters. So if I roll the imaginary sphere along the diagonal, then the sphere will be making contact with the panel, that is the panel is to be protected. So if it is not recommended to maintain this 50 meter along the line. So in another case, if I maintain this 50 meter along the diagonal is equal to 50 meters. Then both L will be less than 50 and the width also will be less than 15. So in this case, if I rotate the sphere in all the directions, the sphere won't be making contact with the panel to be protected. So whenever we are performing design as per the storing sphere method, the maximum distance which we are calculating has to be considered on the diagonal side and it should not be on either length or width of the rectangle. So since here 15 meter is coming, I will be considering the 15 meter along the diagonal of the rectangle and I won't consider on the length and width of the rectangle. So based on this calculation, I have to provide multiple rectangles. So if I am considering a rectangle of 15 meters diagonal, so similarly if it is length and width is 9 meter, then for a rectangle of length 1 meter and width 9 meter, the diagonal will be approximately 15 meters. So which means that at every 12 meters, I have to provide one vertical diagonal. If I am going for rolling sphere method as per NBC 2016 recommendations. So if I calculate this, use this rolling sphere method for huge megawatt scale projects, then the number of air terminals required for the particular site itself will be in terms of few thousands. So since the distance is only 12 meters, so this is one of the reasons for not preferring this rolling sphere method for huge this bigger capacity solar panels. So as per IS 17978, we can install this air terminal on the frame itself and we can connect this earthing to the earthing mat, or that is due to providing earthing ring for the solar panel forms. So we can connect the earthing of this lighting protection system to the earthing grid. So since we are directly working on this structure itself, this method will be considered as non-isolated lighting protection system. Because we are not isolating this air terminal and the structure to be protected. So this is as per the reference of NBC. So here the level of protection has mentioned this code. The maximum distance is only 40, and I have provided an explanation for 12 meter by 9 meter. If I consider a rectangle of 9 12 meter length and 9 meters width, the diagonal will be 15 meters. So there is one that I have to place multiple air turbines to protect the entire area. So this is an example from various forms of exercise. Here, they have performed the design and they have placed multiple items. So here the red forms or air positions, and they have interlinked the earthing of all these earthworks to the earthing mesh. So to this earthing mesh, they have interconnected the main earthing wall of the control room, and all the SPDs and all the other earthing are also connected to this earthing mesh. So this is the recommendation provided by IS 1797. So from this we can observe that the earthing provided for lighting protection system is watered to the earthing of other panel body and equipment bodies. So and most the new latest technology is floating solars. So in floating solars, the solar panels will be installed on the floats that will be floating on the water bodies. So since this object is floating on the water, we cannot provide taller structures. So the height has to be reduced in order to provide proper stability. So if so floating solar panels, they can provide two types of arrangements. So first arrangement is we can mount this air tunnel on the panel body itself. So here we have shown that the air tunnel itself is mounted on the panel body. This is one type of arrangement. So there is another type of arrangement. So in the another type, if you consider the floor, the air tunnel is installed on this floor. So we will be providing some arrangements and we will install this air terminal separately. So here, this air terminal is isolated from the solar panels. We are not directly mounting this air terminal on solar panels. We are providing some isolation between this air terminal and these solar panels. So these are the two types of arrangements that we can go for this floating solar arrangements. And if you take this AV simulation technology, at present we are not using this AV simulation for floating solar because of the stability issues. Because this is floating on this water, and if there are any huge impressions, the stability will be a little bit lower. So we have to provide proper and adequate support to ensure the stability of supporting mass of 5 meters. So if I am going for area simulation, it will be providing 107 meter radius at a height of 5 meters. So mounting the 5 meter supporting pole on floats is difficult. So many people are preferring conventional method for floating solar. If we want to go for this image, we have to provide adequate support to withstand the wind pressure on those conditions. So at present, these two methods are common use. Either we can directly mount the air tunnel on the panel body itself, or we can provide separate support to mount this air tunnel. And if we take this earthing, in the previous image we have shown that all the air terminals are connected to the ground and they have provided earth mat and all these equipments are connected to the earth mesh. So in floating solar, this air terminals and the panels, everything is mounted on above the water body. So for this floating solar, the earthing is done on the water itself. So all these connections will be discharged. That is, if any lightning strike passes, this current will be discharged into the water. So all the energy will be dissipated into the water. So water is that is, if you take a normal water, that is a very good conductor. If you take sea water, that is a much better conductor because of the salt present in the water. But very pure form of water is an insulator. So based upon the type of water, the resistivity varies. So in normal cases, all our normal waters are conductors only. It has very lower resistivity than the soil itself. So for the solar panels, we will be discharging the fault current or either like impulse current into the water itself. All the contents will be discharged into the water. So in this emissions. So till now we have explained about the conventional lighting protection system as per 62305. So the conventional lighting protection systems are also called as passive type of air radiation systems. So the scary streamer emission air tunnels are called the active type of air tunnels. So this EAC air tunnels have separate mechanisms that senses the charges in the cloud and it will send the trigger in advance than the conventional air terminals. So from the name itself you can understand that these air terminals are sending the streamers in advance, that is earlier than the conventional methods. So that is the reason for this name. So these air terminals will be sending the triggers in advance, that is earlier than the conventional methods. So based on the time advance, we will be classifying the model of EAC air terminals. And for this EAC also, we are having four levels, and level 1 will be providing 99%, and level 4 will be providing 84% protection. So, since this is sending the trigger in advance, the area protected by this early stream or emission reactors will be higher than the area protected by conventional reactors. So, the standard has provided a formula for calculating the radius of protection for EAC reactors. So this EAC airturbines are commonly used for solar farms because of its wide coverage area. So if I'm going for conventional as per NBC, I have to provide minimum of 12 meters. At every 12 meters, I have to provide one airturbine. And if I'm going for EAC, the maximum distance will be up to 107 meters. So the radius is 107 and the diameter can be 200 meters. So because of its wider coverage area, these EAC airturbines are commonly used in megawatt field solar process. And this is the formula provided by NFC 13102 for calculating the radius of protection. So if you consider this formula, there are three main parameters. One is radius or another one is H height and third one is delta. So the value of R depends upon the number of protection. So this is a constant value. And second one is the height. So here height is height of the mast above the considered surface. So it is not the height of the mast itself, it is the height of the mast above the considered surface. For example, if we take ground mounted solar as an example, so the height of the solar panels is 2 meters. And if I am providing this gas panel here, so if I consider this, the height that has to consider is above this panel. So the solar will be the height that has to be considered for the formula. And I should not consider this overall height. So for this formula, I should not consider the overall height, and I have to consider the height which is above the structure to be protected. And the height itself is a physical parameter. I can increase or decrease it based on my requirements. And R is a fixed value that depends upon the level of protection that will be decided by the designer. And the third most important thing is the delta. So delta is called as triggering advance time. The triggering advance time is a parameter that differentiates the conventional air tunnel and the early stream emission air tunnel. So the triggering advance time is nothing but the difference in time for the streamer generated by EAC air tunnel and the conventional air tunnel. So in the lab setup, I will be having both conventional, consider this as conventional air tunnel. I will be maintaining the same height for EAC air tunnel also. So I will be considering the conventional air tunnel and EAC air tunnel. So this one is conventional air tunnel and this one is EAC air tunnel. So I will simulate the lighting conditions. I will simulate the lighting conditions and because of induction, this also will be sending some trigger and this also will be sending the trigger. So I will observe the difference in time between this ESC atom and this conventional atom. So the difference in time between the triggers sent by ESC atom and the conventional atom is called as triggering advance time. So the triggering advance time is nothing but time of ESC minus time used by taken by this conventional atom. So that is the difference in time between the triggers sent by ESC atom and the conventional atom is called as triggering advance time. So based upon the triggering advance time only, the radius of production will be varying. So the standard has also mentioned that the triggering advance time value can be in the range of 10 microseconds to 60 microseconds only. So if the triggering advance time of any product is less than 10 microseconds, then the module cannot be considered as the earliest evaluation air terminal. So the value has to be minimum of 10, and while performing the testing, if the value of delta T is coming around 90 microseconds also, I have to consider only 60 microseconds for calculations. I should not consider the 90 microseconds. So even though if it is above 60, while performing calculations, I have to go for 60 microseconds only. I cannot consider the actual value. So based on the three parameters R, H and delta, the radius of protection varies. And in this R and H are physical parameters that can be desired. And the delta T value is specific to the module of ESC atom. So we have performed this calculation for three different modules at different heights and for different levels. So here, we take this 5 meter as an example at level 4. So here the delta T is 25 microseconds, which means that the ESC terminal will be sending a trigger in advance 20 microseconds to compare with the conventional terminal. So if the delta T value is 60 microseconds, which means the earliest emission terminal can send the trigger 60 microseconds in advance than the conventional terminal. So since this terminal is sending 60 microseconds in advance, the radius of protection will be higher than the radius of protection of the module, which sends 25 microseconds in advance. So if it is sending a trigger in 25 microseconds in advance, the radius can be only 65 meter, and if it is 60 microseconds in advance, the radius will be 1.7 meters. So here the height is not from the ground level, the height has to be above the structure to be protected. So since these all parameters are fixed, this calculation is applicable to all the ESC diagonal modules irrespective of the magnitude. So since we are telling that this ESC terminal is providing such a huge area, the testing plays a crucial role. So we cannot blindly tell that this module will be providing 100 meters of protection. So if we compare the protection provided by ESC terminal with the conventional terminal, so if I am going for protection angle method, then for the same 5 meter, the protection radius will be around 17 meters. But for here, the protection radius is around 107 meters. So it is providing protection for such a huge area. So the testing has to be done properly, and it should be ensured that it can provide protection for such a huge area. So if you take the formula, it depends upon three parameters. One is R, another one is H, and third one is delta. Here R depends upon the level of protection. So there is nothing to perform testing on the level of protection. And height is also a designing parameter. So if I am considering a design of height 5 meter, then according to that I can supply the material with supporting code of 5 meter. And the third method is the triggering advance time. So by performing testing, I can verify the triggering advance time. So the proper testing has to be done to ensure the sufficient triggering advance time. That is the most important testing if you take CIKIT. But since even though it is the most important testing, the early simple emission test will be performed at the last. So the first thing is they will subject this CIKIT to harsh environmental conditions. So if you take the harsh environment means initially they will subject this gas terminal to salt treatment. So they will simulating the conditions similar to coastal areas where the salt deposits will be always higher. So they will simulate those actual salty environment and they will expose these air tunnels to those conditions. And second one is if you take industries, there will be some sulfur deposits. So they will expose this air tunnel to such sulfur atmosphere. And after performing this harsh environmental test, they will perform this reaction test without cleaning these modules. So if they are not cleaning means there will be some deposits of salt on the air tunnels. So in actual cases, we won't be cleaning this air tunnel. So in order to simulate those conditions, so they won't clean this module after performing this environmental conditions, and they will subject this air tunnel to electrical test, that is impulse test. Normally, it will be tested for 100 kV, right? 10 by 350 microseconds. So such a huge energy will be separate to this ESC terminal. So, after exposing to this environmental test, if there are any salt deposits, the insulation property of the component will get damaged, will get deteriorated. So, in order to examine this insulation property, even after exposing to this environmental conditions, they will be performing a selected test by subjecting it to a huge energy of 100 kiloamps at every 350 meters engaged. So, after examining such a huge current, they will perform this energy emission test. So, even though this is the most important test, this test will be performed at the last because if any lightning strikes happens, the emission atom will be carrying those energy. So, after carrying those huge energy, whether the atom will be able to send another trigger in advance order. So, for checking that conditions, they will be performing this electrical impulse test first, and after that only they will perform this early stimulation. So, this sequence of testing is very important if you take this EAC atom as an example. So, in India, if you take means we don't have any labs for performing 100 kilowatts at 10 kg per second. So the maximum rating is only 70 kA, but 2 at 8 by 20 meters per second. At present, we are testing, performing the testing at either Turkey or Spain or other countries. We don't have the testing facility for performing this Delta T also. So for that, we have to perform testing at different countries. And since we are assuring that this is providing protection of 107 meters, so the testing of air tunnel is very important. So it should be properly tested and properly tested and certified product can only provide 107 meter radius. Not all the products that are available in the market should be providing this 107. So the proper value of delta T has to be tested at the same time. The testing has to be performed in the same sequence on the same module. So after performing ensuring this only, we can argue assurance for one or one testing. So when we are placing this PSC atom, as I mentioned, the five one or two meter will be provided only for height of 5 meters above the structures. So if the panel height is 2 meters, then the overall height will be 7 meters. So in case if the height of the panel is 3 meters, then the overall height has to be 8 meters. So based upon the structure to be protected, I have to increase the height of the atom. So the most important thing is I have to maintain the 5 meters above the structure to be protected. So similar to the air tunnels of I 1 meter for shadow on this panels, since we are providing 5 meter structures above this pole, this 5 meter pole also can cause shadow. So in order to avoid the effect of shadows, we have to provide sufficient spacing between the air tunnel and the solar panels. So for finding this distance, we have to perform this shadow analysis. So in shadow analysis, we will be performing calculations for finding the length of shadow, maximum length of shadow on different climatic conditions throughout the year. So the calculation will be performed for 365 days. So on 365 days, there will be some days which on which the maximum shadow will be happening. So we will be testing on the shadow length on that particular day, and based upon the length of the shadow, we will be providing sufficient spacing between the gap tunnel and the solar panel, so that the shadow won't be having any effect on the power generation. So, tracing the shadow terminals using this isolated light information system, shadow analysis should be done properly to avoid the effect of shadows on power generation. So, the second most important component is the down conductor system. So, if we take this down conductor system, if I'm going for rooftop solar, then all these data terminals have to be interchanged, and I have to provide one down conductor based on the level of spectrum. If I'm going for level 4, then I have to go for one down conductor at every 20 meters. If I'm going for level 3 protection, then I have to go for one down conductor at every 15 meters. So based on the suitable level of protection, I have to take this down conductors and connect it to the ground. We have to provide the most shortest path to the ground for this lightning impulse line, and the number of joints and the number of bends should be as low as possible. We need to avoid the joints in between, and also we need to avoid the bends also. Short bends also has to be low. And the minimum cross section area of any down conductor has to be minimum 15 square mm. So in many cases we have observed that people are using 16 square mm copper cable or 10 square mm copper cable for this earthing applications of light. But this should not be used. We should use minimum of 50 square mm. So the standard has created provided details about different materials that can be used for lighting protection system and their sizes. So in this they have mentioned that copper, RDTA, aluminum, stainless steel can be used. And for aluminum, they have clearly mentioned that aluminum is not suitable for earthing applications. It cannot be used below the ground because even though aluminum is a very good conductor, the corrosion rate of aluminum will be much higher. So it is not recommended to use aluminum below the ground level. Also, aluminum should not be directly bonded to copper because of galvanic corrosion. So the galvanic corrosion is due to the joining two dissimilar materials. So I cannot make contact of different materials together. This joining itself will result in the corrosion, and that corrosion is called as galvanic corrosion. Hot and breathing also cannot be directly bonded to copper. So if I want to connect these two different materials, I have to go for bimetallic connectors. So this is the standard reference, and in this we can observe that the minimum cross-section area for down conductor is 50 square mm, and for this gap terminal, the minimum cross-section area is 176 square mm. So this 50 is for down conductor and 176 is for gap terminal. So if we take one gap terminal as an example, at this water, we have to provide minimum of two parallel parts. So if any lightning current is coming, it will be dividing into two parts. So since it is having two paths, the current flowing through one path will be little lower. So since the current flowing through this down conductor is lower than the current flowing through this gap tunnel, the conductor sizing of down conductor will be lower than the sizing of down conductor. So gap tunnel will be having bigger size than the down conductor sizing. So we can use lighting protection system components in these different materials, and each material we can use different configurations as well. So if we take the copper as an example, so the copper material can be used in the form of tape, that is 25 meter strips. We can use in the form of rods. So the tape is nothing but strips. It is a rod, it is a rod. So they have provided different materials and different configurations in each materials also. So these many materials can be used, and each materials they can use in different configurations. So for rod, the minimum cross section area has to be 50 square mm. So if I consider this 50 square mm, the diameter will be 8 mm. So the diameter of the rod will be 8 mm, or if I consider in a rod configuration. earthing arrangements. So the standard has already explained about three different earthing arrangements. The first one is type A earthing arrangement. In type A earthing arrangements, we will be having vertical electrodes. And in type A earthing, we will be having a ring surrounding the structure of the product. In type A earthing, there will be any vertical electrodes. And the third one is boost foot earthing. So the boost foot earthing was explained by NFC 7910. NFC standard. So the school food ethic and the type A ethic we will be commonly using for highly soil resistive areas only. So we won't use this for normal soil conditions. We will be using this method only for highly soil resistive areas. So these are the dimensions of the materials if I am going for this earthing configurations. So if you observe this table, they have not provided details for aluminum because aluminum is not recommended to use below the ground level. So they have not provided any details regarding the aluminum. So these are the different dimensions that I have to maintain if I am going for earthing provisions, the earthing for lighting protection systems. So the most commonly asked question by many people is whether we can interconnect the earthing of lighting protection system with other body earthing. So in the previous image itself, we have shown that they have interconnect the panel body and the lighting protection system body with the control system equipment body with common earthing mesh. So the earthing of lighting protection system and other panel body earthing can be interlinked. So the different standards are recommended this. This is from NFC 7800. So here they have provided that when several structures are included in the particular body, the earthing termination system of ESP can be connected to the equipotential body activator. So the earthing can be interlinked. This is coming from NFC and one more references from NEC 2023. So here also they have provided that the earthing of lighting protection system can be interlinked with the other earthing. So here they have shown that all the earthing are connected to main depth terminations. So all the equipment body, everything is connected to this point, and for this the VAE connected to MED, that is main depth termination, and this main depth termination is connected with this earthing system which contains the earthing for LPS as well. So they have done this interconnection below the ground level. So it is always recommended to interconnect the earthing of other system with lighting protection system earthing below the ground level. So while performing installation, we should always maintain the distance depth of 500 mm below the ground level for all the conductors that are related to lighting protection system. So that has to be maintained at 500 mm or all the metallic structures have to be equipotentially bonded. So if there are any metallic components that are laid near to this ground conductor, the chances of flashover will be much higher. So in order to avoid this flashover, we need to connect all the electrical equipments. Sorry, we need to connect all the metallic installations near to this ground conductor system to maintain this equipotential bonding. So these are some of the points that has to be considered while performing this maintenance of lighting protection system. So in lighting protection system, the continuity plays a major role. So we have to examine the continuity of conductors from the atom to the earthing, and all the in-between connections has to be examined, and the value of the resistance has to be checked. These are the important points that we need to check while performing this maintenance. So these are some of our site observations. So in this you can observe that in the first image there was no equipotential body and bolted nuts and screws were found corroded. The second image there was no proper joint at all. So here they have used conductor of lowest cross section area. So in the first one, the conductor sizing was found to be less than 10 square mm. So here they have used only 6 square mm copper cable for connecting this terminal to the grounding. And here they have used 10 square mm copper cable. But as per the standard regulations, we should use 50 square mm. So 6 square mm and 10 square mm should not be. We should minimum of 50 square mm for connecting this electric of light load system. So these are some of observations. So when we are providing this external lighting protection system, we are providing protection against the direct lighting impulses alone. We are not providing protection against surges. So both external and internal requirement is overall protection. And for each and every atom, there should be a minimum of two parallel paths to the ground. And for one down conductor, we have to provide minimum of one earthing. And the overall earthing should not be less than two numbers. The earthing should not be less than two numbers. And the earthing of lighting protection system can be interlinked with the other power system earthings. So second one is internal lighting protection system. So by providing this internal lighting protection system, we can protect this electrical and electronic equipments from the surges. So this indirect effects of lightning strikes can be caused by three sources: lightning strikes on power line, lightning strikes near the power line, and lightning strikes near the structure. So to provide those protection, we have to have surge protection devices. So whenever current flows through any conductor, magnetic field will be produced. So here, the current flowing through this lightning conductor is creating this magnetic field, and this magnetic field is linked with the solar panel modules. So because of this induction, surges will be flowing through this conductor, and this electronic equipment, that is the inverter connected from this cable, will get damaged because of this induction due to the lightning impulse current. So this can be avoided by providing sufficient spacing between this ground conductor and the metallic plates. So if the sufficient spacing cannot be provided, then in that particular case, we have to go for equipotential bonding. In equipotential bonding also, some portion of lightning impulse current will be flowing through this metallic enclosures, and the protection system has to be considered by considering this impulse current also. So in this image, if you observe that there is a fuse provided for protecting this component also. But even though you have provided the fuse, the electronic equipment was damaged and the fuse doesn't operate. So from this, you can observe that the fuse, MCB, and other protection equipments won't operate for the surges, and they are intended to operate only for the power frequencies. So if there are any overcurrent coming at the power frequency, then only this MCB and fuse will operate, and this won't operate for surges. So the surges are very high magnitude but very short duration pulses. So that over this MCBs won't operate for surges. But the damages caused by surges can be as three types. One is interruption of operation. Second one is damage of components, and third one is deterioration of lifetime. So the surge, if it is continuous, the probability of surges can cause the damage at the first time itself will be very much lower. So in some cases, if the surge is continuous, it will result in interruption of operation. The equipment may get turned off, and if you turn it on again, the equipment will start functioning normally. And in some cases, it will result in damage of this components as shown in the image. And in some cases, if the surge magnitude is much lower, then the damage will be very much minimal because we cannot, it is not much sufficient to cause the damage. But if the surge of lower magnitude is continuously coming, then what happens is the lifetime of the equipment will get reduced. So, for example, if we take one electronic device, it is having a lifetime of 5 years, but because of this continuous surges, the lifetime of this equipment may get reduced from 5 years to 4 years. That will be considered as deterioration of lifetime. So, if the magnitude of surges is much lower, we cannot observe the failure of electronic components. So, these surges are considered as silent killers of our electronic devices. So, since these MCBs and other fuses are not operating for these surges, we have to go for a special device called surge protection devices. So if you take the power frequency in India, it is 50 Hz. So 50 Hz is the power frequency in India. So the time period for 50 Hz is 20 milliseconds. So if you consider this waveform, so the time taken for one complete cycle is nothing but 20 milliseconds. So the time taken for one half cycle will be 10 milliseconds. Then 1 by 4 half cycle will be 5 milliseconds. So if you consider the time period of surges, so it will be very much lower if you compare the time period. So in general, the surges will be in terms of 8 by 20 microseconds or 3 by 10 by 350 microseconds. Here we are not mentioning the magnitude. Both 8 and 20 or 10 by 350 both are in terms of microseconds. So the waveform will be like this. So if we take this 8 by 20 as an example, it reaches the maximum value, peak value in 8 microseconds and it will reduce to 50% of the value in 20 microseconds. So this 8 by 20 is both are in microseconds and it takes from 8 microseconds to reach the peak value and 20 microseconds to reach the 50% of the value. If I consider this 10 by 350, it will be reaching the peak value of 10 microseconds and it will be deteriorating to 50% of the value in 350 microseconds. So this is how the surges will be. So since the duration is very much smaller, it is almost 1 by 1000 of a milliseconds, the equipments like the MCB fuse won't be operating for the surges. So the surge protection devices are special equipments that are intended to operate only for this surges alone. It won't operate for normal power frequency coils. So these are very high speed operating switches. At normal operating conditions, it will be acting as an open switch. But if any surges are coming, then if the magnitude becomes greater than the threshold limit, then the switch will become closed. So if the switch becomes closed means it will be connected to the ground. So if the magnitude becomes greater than the threshold limit, it will be connected to the ground. And if the magnitude becomes lower than the threshold limit, then the switch will again open. So during this particular period, the entire supply is connected to the ground. We are dissipating this energy into the ground, and the equipment won't receive this power for this particular duration. Since the duration is in terms of microseconds, we won't sense the turning off and turning on of the equipment. But for the particular microsecond duration, the power supply will be diverted to the ground and the equipment won't be receiving the power supply. So this SPDs are fast acting switches which divert this energy into the ground. So they actually plays a crucial role in surge protection devices as well. So by diverting the surges into the ground, we are protecting this electronic equipment. So there are three different types of SPDs. So the first model is class 1 SPD. In class 1 SPD, the SPD modules will be tested for 10 by 350 microsecond impulse current and type 2 SPD will be tested for 8 by 20 microseconds and type 3 will be tested for 1.2 by 50 microseconds. So since this type 1 SPD is tested for 10 by 350, they are intended to operate for heavy impulse current. So we can observe that the duration is much higher for 10 by 350. So since it is capable of withstanding the service for such a long duration, that are intended for heavy operations. So in general, that will be provided at the point of entry, that is at the main panel of any buildings. And for sub panels, we will be going for type 2 SPD. In solar, we will be normally going for type 2 SPD. And IS 17978 has provided some guidelines on selecting the suitable type of SPD for the solar installations. So they have explained about three different site conditions. With that, I have explained about two commonly available installations. So the first one is we are providing sufficient separation distance between the solar panel and the air terminal components. So here I am providing sufficient spacing so that even though if any lightning impulse is causing the magnetic field, there won't be any interruption. The conductor is laid after the interference area. So there won't be any interruption. So there won't be any induction on this panel as well as the electrical wiring used for this panel. So since I am providing sufficient spacing, there won't be any induction due to the lightning impulse current. So I am providing only type 2 SPD for this system, both AC as well as DC. So this one will be DC and this one will be AC. So type 2 SPD is sufficient for installations if I am providing sufficient spacing. But in any case, if I am unable to provide sufficient spacing, then I have to go for equipotential bonding. So in this case, you can observe there are some equipotential bonding is done. And here we are not providing sufficient spacing. In this case, if any lightning is happening, then there will be some induction on this power line due to the magnetic field. So, in general, if any lightning is coming, it will be in the terms of 10 by 350 microseconds. So, since this induction is caused by 10 by 350 microseconds, the surge protection devices used also should be able to withstand this 10 by 350 microsecond impulses. So, for that only, if we are not providing sufficient spacing, I have to go for type 1 SPD. So, this is the recommendation provided by IS 17978. So, if I can provide sufficient spacing, then I can go for type 2 SPD. In some applications where I cannot go for sufficient spacing, then in that applications I have to go for type 1 SPD. So based on the suitable installations, I have to go for the suitable type of SPDs. So in this webinar, we have explained about why lighting protection system is required and whether the external lighting protection system is sufficient or not. So external lighting protection means we are providing protection only for physical damages only. In order to provide complete protection, I have to go for both external as well as the internal. So for taking care of this external, we will be placing this gap terminal, and for this internal protection, we will be placing this surge protection devices. So we have explained about what are the methodologies that we use for protecting this solar panels from the direct shifts, and how to select the suitable type of SPD for the solar installations. So we have just provided some brief outline about this lighting protection system for solar from the standard references IS 17978, NBC 2016, and some references from 62305.